All right, so I am talking about the regulation of sperm maturation. My name is Elizabeth Warden. It is December 20th, 2022. So, just anatomy overview. The testicles are the site of sperm and hormone production in males. The seminiferous tubules are the site of hormone production within the testicles that produce sperm and hormones and make up 80% of the mass of the testicles in adult males. Interstitial cells of Leydig production. Interstitial cells, also called Leydig cells, produce testosterone within these seminiferous tubules. The seminiferous tubules turns into the epididymis. This structure connects the sperm production of the testicles to the van deferens, and then the van deferens empties sperm into the urethra for it to meet the external environment. So that's just a basic anatomy overview of what's going on. So there's a couple of cells we need to talk about that are within the seminiferous tubules. The Sertoli cells assist with sperm development within these seminiferous tubules. They produce hormones such as activin and inhibin, as well as growth factors, enzymes, and androgen binding protein. And this will turn out to be an important regulatory factor later on. Androgen binding protein is a regulatory protein which binds to testosterone, which makes it more difficult for testosterone to leave the tubule lumen. So this will be important later on in the discussion. Leydig cells or interstitial cells are located between seminiferous tubules and secrete testosterone. These cells are activated when the fetus is developing sex organs. Then they stay dormant until puberty, when they start to produce testosterone again. All within males, of course. All right, so spermatogenesis. This is just the way in which sperm is created. I'm trying to figure out where to put this. So spermatogonia are the cells at the top. They're found just inside the basilamia of the seminiferous tubules, as we were talking about before. These are germ cells and undergo mitosis originally just to create exact copies of themselves. So this is just typical mitosis. So you end up with 8 cells from one after it undergoes mitosis. So then after mitosis, they undergo meiosis. So when meiosis begins, they create sister chromatids and are called primary spermatocytes. So this just is the first stage of meiosis. The cell hasn't split itself yet, but sister chromatids are created within the cell in the first phase of meiosis. So then the secondary phase of, or the secondary part of meiosis occurs, and this creates the first meiotic division. And in this meiotic division, they become secondary spermatocytes, and these sister chromatids physically split apart from each other, creating 2 different cells. So then after the sister chromatids split once, they go under a second meiotic division and split into single chromatids, and these are called spermatids in this case. So these secondary spermatocytes change into spermatids after they divided once again. So they go from diploids to haploids in this. And then these spermatids are then develop into sperm. The process takes place embedded into the Sertoli cells that we mentioned earlier. They develop tails and lose their cytoplasm, An acrosome forms on the tip of the nucleus, which later assists in fertilization because the acrosome produces digestive enzymes to break down the egg in order to enter the egg, because this is a long process that requires enzymatic breakdown in order for the sperm to actually enter the cell, which you can see here that this sperm cell enters into fertilization with an egg to create a zygote. At the end of this process, the sperm are released into the lumen of these seminiferous tubules where they can leave to the open epididymis. The epididymis assists in finishing maturation because the sperm are not fully matured once they finish spermatogenesis. They still need to mature for a little bit longer, which happens in the epididymis before they really reach the vas deferens and are released into the urethra. So it allows for the finishing of this process. This process takes about 64 days. However, these steps are staggered, so there's a constant sperm production. There's always different stages of these things happening at the same time. So the important aspect of this that we're supposed to be talking about within this presentation is the regulation of this cycle of spermatogenesis. So there's multiple places in which this can be regulated, and there are multiple negative feedback loops, as seen in this diagram, that can explain this. So the hypothalamus ultimately creates gonadotropin-releasing hormone, or GnRH, which in turn sends signals to the anterior pituitary gland to create follicle-stimulated hormone, or FSH, and luteinizing hormone, or FH. So FSH stimulates steroli cells, which we talked about earlier, to develop sperm, and LH stimulates interstitial cells, or the Leydig cells that we talked about earlier, to produce testosterone. So there's multiple places where these products are internally regulated. The hypothalamus releases GnRH every 1.5 hours, which is also seen in LH as well with this regular release. They're pretty connected. However, FSH is regulated through a negative feedback loop. The Sertoli cells release inhibin that the FSH stimulate. The inhibin then negatively inhibits the FSH, so it's not able to continue to release and stimulate steroli cells. The steroli cells also create androgen-binding protein, which attaches to testosterone, as we mentioned earlier, making it more difficult for testosterone to leave the cell into the outside of the lumen. This is a negative feedback loop as well, which regulates having an overproduction of testosterone outside the sperm production area, and it also regulates sperm being released out into the cell. So LH and GnRH are also regulated through testosterone. So if there's too much testosterone in the free space, it'll inhibit GnRH and LH from continuing release. As we said, they were tied earlier. And so basically FSH and GnRH together regulate this system. Through all of these vital negative feedback loops, sperm is regulated, and production, and testosterone hormones are regulated as well, which is also a vital aspect of sperm production. So any disruption in these things can cause many issues, such as abnormal secondary sex characteristics caused by a lack of testosterone, infertility caused by a lack of testosterone, mood swings for an increase of testosterone or decrease, or libido control issues on either end of the spectrum. So there's a lot of issues that can happen with this because it's so complex, but if it's working properly, there is a constant production of sperm that is available in an appropriate amount. And that is the presentation.